I'll give a few hints on some of the homework questions. Here's homework problem number 5 from your last web assignment. It shows two long current carrying wires carrying current into the page. So imagine wires poking in and out like this. It gives you the values of the current. In this case, they're both different. And it asks for the magnetic field at a point midway in between them and also up here at this point P. So first, before you do any math, realize that the magnetic fields circle wires. That's our very first right-hand rule. It said if you have a wire carrying current in, like I2 here, point your thumb of your right hand in the direction of the current, and you'll have a circular field curling around like this. That's clockwise seen from where you guys are. So over here in the middle, my fingers would be poking up before they circle around. So this wire has a field up over here in the middle. This wire, thumb in the direction of current in, curl your fingers will be poking down here in the middle. So one field is up, the other field is down. That means when you calculate the value of each magnetic field, you'll need to subtract the two to get the net field. So you can use the long straight wire formula for calculating the field of a wire carrying current I a certain distance away. We use that formula mu naught I over 2 pi d, where d is the distance from the wire to the point. So make sure you take into account the directions of the field when trying to do part A. For part B, it wants to know the field way up here due to the fields of these individual wires. Remember again, fields circle wires. So imagine drawing a huge circle around this wire 1 here, passing through point P. That circle would be going like that. So up here at the top where it passes through P, it would be pointing straight horizontally to the right. So this wire will have a field to the right here up at point P. This wire, if you draw a circle through it, going through point P centered on the wire, a big huge circle, the field will be tangent to the circle. So that's up at an angle like that because the circle passes through the point P like that. So you're going to have one field that's sideways and one field that is up at an angle. Again, you can calculate those fields with the long straight wire formulas. Then you break the diagonal field into horizontal and vertical components, and you add the fields like vectors, like any vector addition problem. You can get your answer.